This topic is on linear inequalities. If you will look at the top of your notes, you'll see a box that gives us the definition of an inequality. A linear inequality in two variables is one that can be written as ax plus by is less than c, is less than or equal to c, is greater than c, or greater than or equal to c. So I want to give you kind of an example here so you understand how it's different than just an equation. So let's start with an equation, ax plus by equals c. We'll just use a simple one, x plus y equals 4. So if I were to do an xy table to get 2 points in order to graph that equation, and I just happen to use the intercepts, I would have the points 4, 0 and 0, 4. So 4, 0 and 0, 4 are those 2 points right there. If I connect those 2 points and I draw my line, then every point on that line is a solution to this equation. Now, if I change the equation to an inequality, and instead of ax plus by equals c, I have ax plus by is less than c, which would give me x plus y is less than 4 in this case. That would mean that I'm not just talking about the points on the line, but instead I'm talking about the region represented by this shading right here, below that line, less than that line. Now, if I also wanted them to include the points on the line, I would put or equal to that line. If I am talking about instead x plus y is greater than 4, I'll do that in a different color, that means I'm talking about the region of points that are above that line. And again, if I wanted it also to include the line, I would have or equal to the line in my inequality symbol. So your inequalities are greater than, less than, greater than or equal to, and less than or equal to. And they refer to regions either above or below a line. And they can also include the points on the line. So let's look at an example and kind of work one all the way through. There are steps here, but I would rather walk you through them than talk you through them. So in example 1, it says graph the equation 3x plus 2y is greater than or equal to 6. So what we're going to do is we're going to start with what is called the boundary line. The boundary line is just the same equation, but it has an equal in it. Just like we did up here when we started with x plus y equals 4. That's to get me the line. Then I look at which region I want, below or above. So to graph that line, I will do an xy table. I'm going to do the intercepts again because they're the easiest. So if I put a 0 in for the y, it would give me 3x equals 6. Divide by 3, and I would get x equals 2. If I put a 0 in for the x, I would have 2y equals 6. Divide by 2, and I get y equals 3. So I have my 2 points, the point 2, 0 and the point 0, 3. Now, because my original equation had an or equal to, so it was a greater than or equal to, I know that it includes the points that are on my line. So I'm going to make that line a solid line because the points are included in my solution. Now I have to decide, am I talking about the points under the line here or above the line? Please don't make the assumption that because it's greater than or equal to, it's always going to be above, because that's not going to always be true. So what I have to do in order to determine that is I have to do a test point. If I test a point in either region and I test it in my original equation, and it turns out to be a true statement, it means that that point is in the region that makes my equation true. So all the points in that region would be true. So I'm going to test the point 0, 0 right here below the line. because that's the easiest point to test. And I'm going to test it up here in my original equation. So I'm going to say 3, take out the x, put in a 0, plus 2, take out the y, put in a 0. Is that greater than or equal to 6? Is 0 greater than or equal to 6? No, it's not. That is a false conclusion. That makes a false statement, which means that this point 0, 0 is false. It's not in the correct region. So it's not the region under the line that I want. The region that I want is the region above the line. And yes, I know in this case, the greater than or equal to actually did refer to above. But remember what I said, that isn't always true. So let's look at the next example. Let me get one sheet at a time here. Our next example, example 2, says graph x minus 3y is less than 4. So we're going to use the same process. We're going to graph the boundary line first, which is x minus 3y equals 4. We will do our XY table. I'm going to pick my points a little differently, however. When one of your variables has an implied 1 in front, it's easier to pick numbers for the other one. You won't end up with fractions that way. So I'm going to pick a 0 for my y, so that would be x minus 3 times 0 equals 4, or just x equals 4, so there's 1 point. And now I'm going to pick a negative 1 for my y. You'll see why in a minute. X minus 3 times negative 1 equals 4. So that would give me x, a negative 3 times a negative 1 is a positive 3 equals 4. Subtract a 3 from both sides, and I get x equals 1. And again, I have 2 points, the point 4, 0, and the point 1, negative 1. Now, before you quickly grab a ruler and connect those points to make a line, let's go back to our symbol here. Our inequality is just less than. There's no or equal to line under it. So that means it does not include the points on the line. And the only way to show that is by making my line dotted instead of solid. That shows that this is the boundary between the two regions, but we don't want to include the points that are actually lying on that line. So this symbol and this symbol are both dotted. When you have this and this, that's going to be a solid line. So now we need to know if we're going to shade above the line or below the line. So I'm going to use my test point. That's the second step. I'm going to once again use the point 0, 0 because it's easy in my original equation, not in the equality, but in the inequality. So that would give me 0 minus 3 times 0 is less than 4. Is 0 less than 4? Yes, it is. That is a true statement, which means that my test point 0, 0 is in the correct region, the true region. So I'm going to shade that whole region, which you notice is above the line, even though it was a less than inequality. So always run a test point. Don't just assume you know. All right, the next thing that we're going to do is put 2 of these at the same time on the same coordinate plane. And when you do that, it's called a compound inequality. We're going to start with the intersection of 2 lines. The intersection means that it's the region that applies and is true for both given lines. So we're going to do them one at a time. So for example 3, let's start with 2x plus 4y is greater than or equal to 5. We'll do the boundary line, which is 2x plus 4y equals 5. We need an xy table. I can either do the intercepts or just pick points, but since neither one of my variables has a 1 in front of it, it's going to be easier just to do the intercept points. So I'm going to put in a 0 for the y and then a 0 for the x. A 0 for the y is going to give me 2x equals 5. divide by 2, and I get x equals 5 halves. For ease of graphing, I'm going to change that to 2 1/2, a mixed number. Now I put the 0 in for the x, and that's going to give me 4y equals 5. Solve for y, and I get y equals 5/4. Again, for ease of graphing, I'm going to use 1 1/4. So I have the point 2 1/2, 0, which is right about here. I'm just estimating. And then I have the point 0, 1 1/4. 0, 1, and a little bit above that. Because this was an or equal to symbol, I know that I want a solid line connecting those 2 points. So my boundary line is the line passing through those 2 points, and it is solid. Now I have to test the point 0, 0. So we're going to test 0, 0. I could pick any point to test, by the way. I just picked 0, 0 because it's the easiest. So in my original equation, that would give me 2 times 0 plus 4 times 0 is greater than or equal to 5. Is 0 greater than or equal to 5? No, that is false. So 0, 0 is not in my correct region. So I'm going to shade the region above the line instead of the region that contained the false 0, 0. So we shade like that. Now, on the same coordinate plane, we're going to do our second inequality. X is greater than or equal to 1. Its boundary line is just x equals 1. And I know that x equals is a vertical line passing through 1. Let's do that in a different color. So I know that the graph of that line, because it's an or equal, is going to be a solid vertical line passing through x equals 1. So it looks like that. And now with respect to this blue line, I also have to test the point 0, 0 in my original equation. So there isn't even a y to put a 0 in for, so I just put the 0 in the x spot. Is 0 greater than or equal to 1? That is also false. So that means that the 0, 0 is not in the correct region for the blue line either. So I'm going to shade this side of my blue line. Now with a pencil, I'm going to try to show you this. Because my inequalities said and, that means the intersection of these two, I need to look at where the double shading is. And the double shading, where you have both pencil and pen, is this region to the right of the blue line, but above the penciled line. So I'm trying to make this darker so you can see this. It's always a good idea to have 2 colors of pencils, 2 colored pencils, so you can actually read that. But I think you can see there, that is the intersection. So that region is the solution to that compound inequality. Let's try one more. That is a compound inequality. This time we're going to look at what's called the union. That's when you have an or. And all that means is it's both regions together. It's not where they intersect. It's just the 2 regions. So let's go through the process again. Our first inequality is 3x minus 5y is less than 15. I'm going to jot down that this is a dotted line to help me remember because it doesn't have the or equal. And then x is greater than 4. That is also a dotted line. By the way, they don't have to match. You could have one solid and one dotted. That's okay. So the boundary line for our first equation would be 3x minus 5y equals 15. XY table, in order to graph it, I'll use the intercepts. If I put a 0 in for y, that would give me 3x equals 15. Divide by 3, and I get x equals 5. So I have the point 5, 0. Now if I put a 0 in for the x, that's going to give me negative 5y equals 15. Divide by negative 5, and I get y equals negative 3. So I have the point 0, negative 3. We're going to connect those 2 points, like we said, with a dotted line. So a dotted line, meaning the points on the line are not included. We need to test 0, 0 to see if it's in the correct region. In our original equation, is 3 times 0 minus 5 times 0 less than 15? Is 0 less than 15? Yes, it is. So that is true, meaning 0, 0 is in the correct region. So I'm going to try to shade this from that angle. I'm looking at that region above that line. And now let's look at our second line. X is greater than 4. The boundary line is x equals 4, and I know that x equals is a vertical line, dotted in this case, going through x equals 4. So I'm going to make my dotted line here. Once again, I have to test the point 0, 0. So in my original equation, there's not a y, but I put in a 0. Is 0 greater than 4? No, that's false. So with respect to this line, let's do it in blue this time. The 0, 0 is in the wrong region, so I'm going to shade this side. Now, if we were looking for the intersection, I can see where it intersects right here, but I'm not. The word is or. So I was looking for the union, meaning I'm done. It's just all of this shaded region, all of this, and all of this. It's just together. Either one of those. That's the union. So in the conclusions, it says, when graphing the intersection of two inequalities, the key word is and. When graphing the union of two inequalities, the key word is or. The one that has and is like example 3, where you have to darken where they intersect. With or, you just leave the two shadings alone. Finally, in example, this last example, match the graph, I have screen captured two graphs from a graphing calculator, and we want to know which one matches the equation y is greater than or equal to 3x minus 6. Well, both of them, if you notice, have the line graphed in the exact same spot. The difference is one of them shaded to the left and one shaded to the right. So how do we know which is correct? Well, we're going to run a test on the point 0, 0. So I'm going to test in my original equation 0, 0. So here's my original equation. 0 is greater than or equal to 3 times 0 minus 6. Is 0 greater than or equal to negative 6? Think about it a minute. That is true. So the region that should be shaded should include the point 0, 0. Well, this one doesn't, so that's not correct. This one does. This one is the right answer.